My name is Raymond. Today I'm going to present our final project. The topic is LLM-based agent service. My partner is Chang Hui. What we designed is an AI-powered customer service for telecom. The goals for this project is to replace live representatives with AI assistant. This project is able to support such kind of functionalities like plan search, personal recommendations, plan modification, and we also consider some security aspects like prompt injection, user authentication. As for the system architecture, I would like to introduce a bit about what we use in this project. As for the backend, we use C#.NET 7 to build out the backend API. And we also connect with LLM service. Specifically, the model is OpenAI GPT 3.5 Turbo. As for the data, we deployed the SQL Server in the Docker. And we also use the local, the backend, the local local memory cache to cache some history data for implemented like the multi-turn conversation. And we use HTML and JavaScript to work out a chatbox UI as our front end. We also use prompt engineering as a methodology to communicate with OpenAI. So now this is a core end-to-end workflow. So basically, once the backend API receives the request from the user, we will send this information to OpenAI, which help us to pass the user input and work out SQL as the response. And once we tell it's executable, we will execute that SQL to fetch or to update data in our own SQL server. And we will hire OpenAI again to encapsulate the response from SQL and to generate a user response. So as for the prompt engineer applications, because we want to light OpenAI servers better, so there are some tactics. The first one is pre-learn table schema so that OpenAI is able to know what will be the expected SQL as a response. And we also need to enforce OpenAI to learn the response format, T-SQL or JSON. Hence, it's better to give OpenAI some specific examples so that it will understand better what will be expected behavior. To support multi-turn conversation, not only just one sentence as input, we need to give the whole history conversation information. So we use the local memory. And finally, we also use some skills to prevent SQL injection and enforce privacy authentication as well. So there are some lessons. So LLM can forget initial requests, because especially when conversation goes deeper. And for example, like the format is not as expanded anymore. So we need to consider some extra logic. And we also need to use some tricky skills to highlight what will be the user inputs to avoid the injection risk. And we also got some suggestions from classmates who watched this demo. They give us some future improvements. And now I'm going to demo our project. So this is our front end. We're just starting from high. And say I want to check some specific plans based on my personal preference, like the cheapest one. Oh, there is a random exception, but let me try that again, probably because. So this is the expected response because it just paused my input as turned to be a SQL and response, and then we execute in the backend, execute the SQL in the SQL Server and response, the user call result. Okay, So basically, I'm also able to change or upgrade my personal plan, my current plan, but limited by time. So I'm going to skip that. So thank you for watching, and this is our final presentation. Thank you.